we have to prove the following identity. We have the sec of alpha divided by 1 plus tan alpha. We have to prove that it's equals to the cosec of alpha divided by 1 plus the cot of alpha. In order for us to prove this, we have to simplify the left hand side and the right hand side concurrently, but let's start first with the left hand side. We have the left hand side, which is equals to the sec of alpha divided by 1 plus tan alpha. We express this as sec alpha divided by 1 plus tan alpha, and the sec of x is equals to 1 divided by cos alpha, and this is divided by 1 plus the tan alpha, which we express as sin alpha, divided by the cos of alpha. Remember that if we had a divided by b plus c divided by b, this is equal to a plus c, all of which is divided by the b. We are going to express this one so that the denominator matches the denominator that we have, the cos of alpha, so we can express the 1 as cos alpha divided by cos alpha, and we know that cos alpha divided by cos alpha is equals to 1. And this will be equals to 1 divided by cos alpha divided by the 1, we express it as cos alpha divided by cos alpha, and we have this plus sin alpha divided by the cos of alpha. Since the denominator here and that denominator are the same, we are going to express it like the way that we expressed 1 divided by b plus c divided by b, which was equals to a plus c, all of which was divided by b. So this will be equals to 1 divided by cos alpha divided by the cos alpha plus sin alpha, and this is divided by the cos of alpha we have 1 divided by cos alpha, and we are changing this division, we are converting it into multiplication, and when we do that, the denominator becomes the numerator. So the cos alpha moves from the denominator to the numerator, and the cos of alpha plus the sin of alpha moves from the numerator to the denominator. That cos alpha and that cos alpha cancel out each other, since we now have a multiplication in between, and this will be equals to 1 multiplied by 1 divided by the cos of alpha plus the sin of alpha, and all of this will be equals to 1 divided, so 1 multiplied by 1 will be equals to 1, and in the denominator we still have the cos alpha plus the sin alpha. The right hand side is not clearly identical to 1 divided by cos of alpha plus sin alpha, so we are going to take the right hand side and we are going to simplify it. So now we have the right hand side. So let's try to simplify it to see if it will be equal to 1 divided by the cos of alpha plus the sine of alpha. So we have this as the cosec of alpha divided by 1 plus cot alpha, and this is equals to the cosec. We express the cosec as 1 divided by sine alpha. This will be divided by 1 plus cot alpha. Cot alpha is equals to the cos of alpha divided by the sine of alpha. Since the denominator is the sine x, we are going to express the 1 as sine alpha divided by sine alpha. This will be equal to 1 divided by sine alpha. This whole thing is divided by the 1. We express it as sine alpha divided by sine alpha plus the cos of alpha divided by the sine of alpha. Remember that we said that if we had 4 divided by 3 plus 7 divided by 3, this we can express it as 4 plus 7, all of which will be divided by the 3. Since the 3 is common in both the denominators, this will be equals to 1 divided by the sine of alpha and this whole thing is divided by the sine alpha plus the cos of alpha divided through by the sine alpha. We have 1 divided by sine alpha. The same process again, the division is changing into multiplication, and when it changes into multiplication, the denominator becomes the numerator and the numerator becomes the denominator. Now, the sine alpha and that sine alpha will cancel out each other, and this will be equal to 1 multiplied by 1 divided by sine alpha plus the cos of alpha, and this will be equal to 1 multiplied by 1 will be equal to 1, and we are still dividing by the sine alpha plus the cos alpha. The right hand side is giving us 1 divided by sine alpha plus cos alpha, and even here the left hand side gave us 1 divided by the cos of alpha plus sine alpha. We can conclude that the left hand side is equal to the right hand side.